ME Group of 3 presents Everyday Examples of Applied Mechanics. This is Episode 1, A Good Grade, presented by Austin Poe, Industrial Engineering.
Andrew Stefanowski, Manufacturing Engineering.
Hannah Cargill, Bioengineering. Example 1, car jack. The car jack in this example is used to raise cars to make repairs simpler. When the lever is pressed, the platform raises and applies a force to the underside of the car using pneumatics inside of the body of the jack. In this example, we are looking at a car jack in a static position, and the force is being applied downward by the person standing on the jack. In the free body diagram, the force from the weight is shown downward, and you can see the equilibrium force on the underside of the platform going upward. There are support reactions on the bottom of the jack in the AY and BY directions. They're only in the Y directions and not the X directions because they are wheels and not static supports.
Example 2, Crane. This is an example of a gantry-style crane. In this example, it is considered a static object, but in real life it is a dynamic object that can rotate 360 degrees. Its purpose is to move heavy objects to a place where you want to put them, but you can't simply move them yourself. This is the crane free body diagram. For this purpose, we're looking at it in a static position. At points A, B, and C, there are support forces in the X and Y direction preventing any such translation. There's also forces that can be applied to the boom at point M. One design improvement would be to change the actual material used on the boom or changing any of the support materials affecting the crane.
Example 3, step ladder. The step ladder is used to allow people to reach higher than themselves. The ladder is constructed of welded steel with wheels at the bottom. There are supports on the bottom that lock the ladder into place when weight is applied on the steps. In the free body diagram, we show the downward force of the weight of the person at the top of the steps. When the weight is applied, there are support reactions at the base in both the X and the Y directions because of the solid supports at the base of the ladder. If there's no weight applied to the top of the ladder, there's only a support reaction in the Y direction because the ladder is only supported by wheels at that point. Since there's no force being applied to the rails of the ladder, the rails are considered zero force members in this example, so there are no forces shown in the free body diagram. This structure could be improved by adding additional supports in the base or in the railings of the ladder.
Example 4, OD grinder.
Hey, this is Andrew Stefanowski again here. So this is another example of a grinding unit. This is an OD grinder. Basically, what's happening here is you've got a round workpiece that is held between centers. So there's a female centers in the blank, and then these are male centers. This is called a dog, and this is actually clamped onto the material and being rotated here by the machine. The external force here is the grinding wheel on the blank. And so yeah, this is the only thing that's supporting, the only support reactions on this are at both ends of the material. And you can see that on the next free body diagram here.
As we see in the accompanying forced body diagram here, while this system is actually dynamic, there is rotation of the workpiece and the machine itself. We're going to assume that this is static. So therefore there's going to be support reactions in the A point and B point here with an external force of the wheel pushing down on the workpiece. One of the improvements to this system could be the addition of an additional support in the middle of this workpiece to help compensate against the external force of the wheel. Example 5, dead screw grinder.
Hey, this is Andrew Stefanowski here again. So we're here with a dead screw unit. So what's happening here is there's a cylindrical workpiece that is being rotated by a regulating wheel. We've got multiple support reactions here. We have a backstop that's holding the tool in place. We have a work blade here that the tool is resting against. We have a lever pressure on the tool with a bearing that's allowing it to rotate. The external force here is the grinding wheel actually grinding onto the material. So yeah, as evidenced by the next free body diagram over here.
Here we see the force body diagram for the dead tree grinding fixture here, and once again it's a bit of a complicated fixture here. There is a lot of dynamic motion, but again we're going to assume that it's static. So for instance, the regulating wheel does rotate this workpiece here, which actually will generate a support reaction of Bx against the backstop of Ax here. So those will offset. You also have an external force of the wheel. You have clamping support reaction at Cy. You also have a support reaction at the regulating wheel as well. How we can improve this fixture is if you have a really long workpiece and it extends beyond the regulating wheel length, you could add an additional support at the front to kind of offset the force of the grinding wheel.